Good evening, Bearcats. This is Unit 5 review, and we're going to get started here. The first one on your review was to describe the right and left-hand behavior of the graph. So let's take a look. I like to use a visual. So we know that this graph is negative. It starts out as a negative, so that would mean on the right side of the graph you would go down. And it's an even exponent, therefore on the left side it would do the same. All things would be even, and therefore this is a down-down situation. Let's move on. Okay, and we have another here that we're going to look at in behavior. And let's see, this is a positive 5, therefore on the right it would go up. It is an odd exponent, therefore on the left it would be opposite the right. So they would be opposite each other, and therefore it would rise on the right and fall on the left. All right, next we want to find the polynomial with these given zeros. These are the zeros or the roots or the solutions. So to find the polynomial, we're going to kind of work our way backwards. We're going to create from these roots and or solutions here, we're going to create factors. So the first factor for the solution of -1 would have been x plus 1. The solution or the factor for 2 would have been x minus 2, and the factor for -3 would have been x plus 3. All right, so we want to multiply these back together to get our polynomial. So the first thing we're going to do is go ahead and multiply these two together, and we would have, I'm having a little trouble with my computer tonight, so I apologize for all the weirdness. All right, so we would have x times x, which would be x squared. X times 3 would be positive 3x. -2 times x, -2x, and -2 times 3 would be a -6. Of course, you combine the like terms in the middle, and you would get x squared plus x minus 6. Then we would need to multiply that times the x plus 1. All right, let's go ahead and distribute. X times x squared would be x cubed. X times x would be positive x squared. X times -6 would be -6x. Then we would go with the 1. 1 times x squared is x squared. I'm going to line them up underneath. Positive x squared. Sorry about that. 1 times x would be a positive x, and 1 times -6 would be a -6. And you draw a line and add down. I'm going to kind of move over here since I'm running. Oh, now I got a little more room. Never mind. I can do it over here. So I'm going to add down, and I would get x cubed. I have an x squared and an x squared, so positive 2x squared. -6 and a positive 1 would be a -5x minus 6. And there's our polynomial. Go Bearcats. All right, for number 4, we're asked to find all the real zeros of the polynomial and determine the multiplicity of each. Okay, we're going to look first. Remember, there are several things that we need to do when we're trying to find polynomials. There are processes we need to go through. Let's just talk about that. First, you always want to look for GCF. After you GCF, if you have 4 or less terms, you want to, or if you have 4 terms, you want to try to maybe factor by grouping. If you have 3 terms, that would be, and it's a quadratic, you want to maybe try to just factor. And if you can't do that, then you'll use all the upper degree polynomial stuff, your P's over your Q's, your Descartes chart, and your synthetic division. All right, but you don't want to do all that till you try the other stuff first. All right, in this particular case, let's take a look. I believe we can GCF for sure. They all have an x squared, and that would leave us x squared plus 6x plus 5. And now we have a quadratic, which I believe we can factor. Keep our x squared. That is a factor. So x and x, multiply to 5, add to 6 would be positive 5 and positive 1. And therefore, we have x squared. Our 0 here would be 0, which happens twice because of the squared. So it has a multiplicity of 2. For this one, our 0 would be -5 with a multiplicity of 1. And here would be a -1 with a multiplicity of 1. Now we should have 4 solutions. There's 2 zeros and a 5 and a -5, -1. That's 1, 2, 3, 4. That would match up with our degree. And I think that's it. Just a little side note, if it has an even multiplicity like right here, it would cause a bounce in our graph. Okay, go Bearcats. All right, just a little side note here. If you were to have a problem similar to the last one where we were asked just to find the zeros and you had fractions in it, clear out your fractions. Please clear out your fractions. Here's just an extra example right here. These are all have a denominator of 7, so you could multiply your entire and it should equal 0. You could multiply your entire polynomial by 7. It would clear all your denominators, and you would be left with 2x squared minus 5x minus 12 in this case. So let's go ahead and finish this one. So we'll have a little extra practice. I believe in this case you would need to use flip and divide. So we're going to take this 2 over here and put it with the 12. That would leave us with x squared minus 5x minus 24. And now we can factor. And we have x, and I believe it'll be a 3 and an 8. With negative 8 and a positive 3, that would give us a negative 24, and combined would give us negative 5. But don't forget, we got to divide the 2 back in. And so, therefore, our factors for this would have been x plus 3/2 and x minus 4. And we're really trying to get to our zeros. So our 0 here would be negative 3/2 and 4. Go Bearcats. All right, on this next problem, we're asked to use long division to divide, and we're supposed to divide 5x squared minus 18x minus 8 by x minus 4. Oops. So we're going to long division by x minus 4. All right, let's go ahead and talk about this. X times something gives us 5x squared. That would be a 5x. 5x times x, just checking it out, is 5x squared. And 5x times negative 4 is a negative 20x. All right, the next thing we need to do, remember, we're going to draw our line, but before we do anything, we're going to change all the signs because we're subtracting everything. So this becomes a negative, and this negative would become a positive. Now, these should always cancel. We're going to add down, and we're going to get 2x minus 8. And then x times something gives us 2x. That would be a positive 2. 2 times x is 2x. And 2 times negative 4 is negative 8. Draw our line. Once again, subtract everything. Change the sign. So this becomes a negative. This becomes a positive. And they both cancel. And we get a 0 remainder. Ooh, go Bearcats. So this 5x plus 2 is the result of our division. All right, for number 6, we have another long division problem. We're asked to divide x cubed minus 3x squared plus 25x minus 75 by x minus 3. All right, and let's do the same thing. So x times something gives me x cubed. That would be x squared. X squared times x is x cubed. X squared times negative 3 would be negative 3x squared. Be really careful. We're going to draw our line, but before we do anything, change the sign. So subtract, and this negative becomes a positive. Sorry, my pen's not working very good tonight. All right, so these cancel, and in this case, these cancel. Don't let that weird you out. We still have more stuff to go over here. So we're going to bring down your 25x minus 75. And we can still go one more time because x times something gives me 25x. That would be a positive 25. So 25 times x is 25x. And 25 times negative 3 is negative 75. Draw your line. Oh, hold on. So change all the signs. This becomes a negative. Negative becomes a positive. These cancel, and once again, we have a 0. So go Bearcats. Please make sure on all of your long division and synthetic division that everything is in standard form, that you're going from the highest degree polynomial to the smallest degree polynomial or to your constant. And also please remember that if you skip a degree, like you go from a 4th degree to a 2nd degree and you skip x cubed, you've got to put a 0 placeholder in there, particularly important with synthetic division. Just a good reminder. All right, we're going to do number 7 next. All right, here's number 7. Oops, this really should not be this. This really should be the factor x plus 1/2. Sorry about that. All right, so now let's use synthetic division to divide this polynomial. Let's use synthetic division to divide this polynomial. All right, I think we have a third degree, a second degree, a first degree, and a constant, so we didn't skip anything, and we are in the right order, so let's write out our synthetic division. Again, I'm sorry about my computer tonight. All right, so we're going to write out 10, 59, 47, and 10, and we're going to synthetically divide. All right, because this is the factor, then the solution would be -1/2, and we use the solution, or the 0, or the x value to synthetically divide by. So be really, really careful with that. So we're going to synthetically divide by negative, let me get a little extra row in here, -1/2. All right, first we bring down the 10. Half of 10 is 5, and that would be a negative because of the -1/2, so -5. When I add down, I get 54. Half of 54 is 27, and again, that would be a -27. So when I add down, I get a 20. Half of 20 is 10, and that would be a -10. Oh, look how nice that is, and that would be a 0. All right, so in division, we then ended up with 10x squared plus 54x plus 20 when we divided. All right, go Bearcats. Okay, we're going to practice again our synthetic division. We're just asked to use synthetic division to divide. And so we have a cube and a square and an x to the first and a constant, so we're in good shape. So let's go ahead and set up our synthetic division. It would be -4, -13, 37, and 10. And we would synthetically divide by, what would it be? This is the factor, so the solution is -1/4. Be really careful about that. So, oops, what happened there? There we go. All right, so, oops, what happened there? Did I erase something? Where did I go? Ah! Wow, I must have hit erase. Let me see if I can go back. Redo. Don't know what happened there. All right, well, I'm going to go into 8 and write it again. Sorry about that. All right, back to number 8. I apologize for that. So we're going to divide by -1/4. All right, we bring down the -4. Negative times negative is going to be a positive, so let's not worry about that now. We know it's positive. And 1/4 of 4 is 1. So when we bring down that, we would have a -13 and a 1. That would be a -12. Negative times negative is a positive, so we don't have to worry about that. We know it's positive. 1/4 of 12 would be 3. We add down, we get 40. And now we have a negative times a positive, so we're going to get a negative. And 1/4 of 40 is 10. Woohoo! That's a 0. Happy day. All right, and so we divided synthetically, and our result now was a cubic. It is now a quadratic at -4x squared minus 12x plus 40. There we go. Go Bearcats. Let's go on to number 9. All right, in number 9, we're asked, we're told that -1 is a root, which is our 0. We're asked to use synthetic division and then to factor the polynomial completely and list all the real solutions of the equation. So I'm going to go over here and I'm going to kind of do my little line over here, and I'm going to write my factors, and then I'm going to write my solutions over here, and I'll do all my work on this side. So my first factor, I know if x is -1, my first factor was x plus 1. Just so we know that. All right, synthetically, though, when we divide, we're going to use the -1. Let's set up our synthetic division. We would have a 1, a 4, a -1, and a -4. The next thing we're going to do is we're going to synthetically divide by -1. Bring down the 1. 1 times -1 is -1. Adding down, we get a 3. -1 times 3 is a -3. Adding down, we get a -4. Negative times negative would be a +4. Woohoo, we got a 0, which is kind of what we were hoping. So we know -1 works because we were told that. Now we're left with a quadratic at x squared plus 3x minus 4, which we can factor to find our other two factors, x and x. And then multiply to -4 and add to 3. So -4 and, positive 4, sorry, and a -1. So our factors are x plus 4 and x minus 1. Therefore, our solutions are -1. Our solution is -4, and our solution is +1. Go Bearcats. Okay, this time they want us to write our polynomial in fully factored form. So they want us to write all the factors. Well, the first two factors we're given is x minus 5 and x minus 3. And we want to write all the factors. Since we have a cubic or a third degree polynomial, we should have 3 factors. Right now we have 2, which we know then the solutions, which we're not writing for the answer, but we need to know, would be 5 and 3. We're going to use those to synthetically divide twice, once by 5, once by 3, and the result should be our last factor. All right, so synthetically dividing, we would have a 1, a -6, a -1, and a 30. And so first, we're going to divide by 5. All right, and we're going to bring down the 1. And 1 times 5 is 5. And that would give us a -1, and that would be a -5. That would be a -6. And 5 times -6 is -30, and that's a 0, which we would expect. Yippee. So now we have a quadratic. We have x squared minus x minus 6. We could factor that, or we could use synthetic division now with this new polynomial. So let's just try that. So we're going to take the 1, the -1, and the -6. And since we already used the 5, we're going to use the 3. So we're going to bring down the 1 and get a 1. 1 times 3 is 3. 3 and -1 would be 2. And 2 times 3 is 6, which would be a 0. Yippee, yippee, yippee. Now we have a linear. This was a quadratic. And this is linear factor, which would just give us an x plus 2. Which is our last factor, x plus 2. And there's our solution. All right, keep going, Bearcats. You're going to do great. All right, these next two, we're going to take the opportunity to do long division again. We're going to take the opportunity to look at some long division. Before we do that, I want to go back to this problem one more time and talk about these factors. So remember that x minus 5 is the factor. The solution is 5. So if you're writing a factor, it's this way. If we're synthetically dividing, we use this. And then there's also something called a function value. And you could say this is f of 5. And that would be your x value is 5. So you knew that if x value was 5, then the factor would be x minus 5. If you were synthetically dividing from this form right here, x of 5, you would synthetically divide by 5 as well. That's important. Just a little extra side note there. This is a plus info, so make sure you're taking note of it. All right, well, let's move on to 11. Okay, like I said, we're going to do long division. So let's go ahead and set up our long division problem. We're going to have 3x cubed plus, 3x cubed plus 17x squared plus 28x plus 12. And we're going to long division by 3x plus 2. 3x plus 2. All right, let's go back and practice this a little bit. So 3x times something gives me 3x cubed. That would be an x squared. X squared times 3x would be 3x cubed. Now, 2 times x squared would be 2x squared. Draw our line, and then bell go off in your head. Ding, 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 ding. Change the signs. So this is a subtraction. This positive number will become a negative. Cancel this out, add down, and you get positive 15x squared plus the 28x plus the 12. All right, go again. 3x times something gives me 15x squared. So that would be a positive 5x. 5x times 3x is 15x squared. And then 5x times 2 is 10x. Draw a line, and then ding, 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 ding. Change the signs, change the sign, change the sign. So we have a positive 28 and a negative 10. We have a positive 18x plus 12, and we're almost done. So 3x times something gives me 18x, and that would be a positive 6. So 6 times 3x is 18x, and 6 times 2 is 12. Draw our line, and ding, 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 ding. Change the signs. That cancels, 0. Wow, we did long division, and that is our result. Okay, this is your number 12, and you were supposed to divide by x squared plus 4x plus 4. And I'm just going to let you know when you do that, you should get a 0 remainder. I want to do one where we get a remainder that's not 0 and just make sure we're really clear on how to write that solution. So this is just an extra problem, but I think a very, very important one if I would take the time to do an extra problem at this point. So we want to divide x squared x cubed plus 4x squared minus 3x minus 12. And we're going to divide by x minus 3. Okay, and I just want to do this problem because I want to make sure that we're clear on what to do with a remainder other than 0. All right, so the first thing we're going to do is x times what gives me x cubed? That would be x squared. X squared times x is x cubed. X squared times negative 3x is negative 3x squared. Draw our line, and then ding, 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 change your sign. This becomes a negative, and this one becomes a positive. And when I add down, I would get 7x squared. I would get minus 3x and minus 12. All right, going again. X times something gives me 7x squared. That would be a positive 7x. So 7x times x is 7x squared. 7x times negative 3 is negative 21x. Draw my line, and then ding, 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 change the signs. Minus, this subtraction becomes a positive. This becomes a positive. So when you add down, you would have a positive 18x minus 12. Let's go one more time. All right, so x times what gives me 18x? That would be a positive 18. So 18 times x is 18x. Now, 18 times 3, 18 times 3 would be 54. And actually would be a negative 54. And then draw our line, and ding, 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 change your signs. This becomes a positive. When I take negative 12 and a positive 54, I'm going to get a positive 42 remainder. And I can't go anymore because x times something can't give me 42. This is my remainder. It's positive. Because it's positive, I'm going to write a positive sign. If it were negative, I would write a negative sign instead of a positive sign. So it's plus, and then it's going to be 42 over the divisor x minus 3. So please be really, really careful. Whatever the number is, you put it over the divisor. If it's a positive, you put plus that fraction. If it's a negative, you put minus that fraction. Hopefully that will help you. Make sure you've practiced plenty of those. There's more in your textbook on page 159 if you want to do some extra practice. And check your answers in the back of the book. All right, now we're on to complex numbers. Okay, for 13, our problem is 2i minus parentheses 5 plus 9i. You need to make sure you distribute a negative. You would get 2i minus 5 minus 9i. And remember, all complex numbers need to be in the form of a plus bi. This is the real part, coefficient in front of the imaginary part. So the real part here would be the negative 5. The imaginary, complex imaginary would be the 2i minus 9i. That'd be minus 7i. That would be your final answer. Go Bearcats. And that would be in a plus bi form. All right, in this next problem, we're multiplying two binomial complex binomials, so let's do that. So we're going to have 5 times negative 5 would be negative 25. And we'd have 5 times negative 8i would be negative 40i. And then we would go I times negative 5 is negative 5i. And I times negative 8i is negative 8i squared. All right, negative 8i squared. So the I squared really is a negative 1 times negative 8 makes the 8 become positive. Please be careful about that. So now what do we have? We want to put the real stuff, so the negative 25 and the positive 8 together gives us negative 17. Negative 40 and negative 5 gives us a negative 45i. That is our answer in A plus BI form. Go Bearcats, let's keep going. All right, let's take a look at this problem. We have a binomial squared minus a binomial squared. Let's use our binomial squared shortcut to get this one. So I'm going to keep the parentheses for a few minutes. And if we do this shortcut, we would take the first term, negative 2, and square it. That would be positive 4. Then we would multiply 2 times negative 2. That's negative 4. Times negative I would be positive 4i. So plus 4i. And then we would take the last term, negative I squared, which would be negative times negative would be a positive I squared. But I squared would be negative 1. Okay, be careful. Let's go ahead and clean this one up. So 4 and negative 1 would be 3 plus 4i. All right. And then we're going to subtract, but we're going to do this one next. So again, use our shortcut. Negative 2 squared is 4. 2 times negative 2 is negative 4 times I, which would be negative 4i. And then positive I squared is positive I squared. But I squared is negative 1. So we have a 4 and a negative 1. That's also 3 minus 4i. All right, 3 minus 4i. All right, so the next thing we're going to do is we're going to distribute the negative between, the subtraction between. So we have 3 plus 4i minus 3, and then it'd be plus 4i. Oh, look what happened here. So we have a 3, and we have a negative 3. They cancel, but we have a 4i and a 4i. I believe we get a I. Go Bearcats. Okay, Bearcats, we're getting close. Number 16. We're going to have several on this last page. I think we have 3 on this last page that we're going to omit. So we're getting pretty close to being done. 16 is negative 3 minus the square root of 7, and the I is on the outside. And we're asked to write the complex conjugate. Well, remember the conjugate, you keep this term and you keep this term, but this sign in the middle changes. So this becomes a positive. So we have a negative 3 plus the square root of 7i. That's our conjugate. Go Bearcats. That's all you have to do. Don't make that one too hard. Next, number 17. All right, we have negative 8 minus 2i all over 5i. And we're asked to write this in standard form. That means we don't like to have any complex numbers in the denominator. We can have a denominator but no imaginary parts. So we're going to multiply by the conjugate. The conjugate of 5i would be negative 5i. And then we do that at the bottom. Then we have to also make negative 5i at the top. All right, let's go ahead and look and see what happens at the bottom. That's how we'll know if we did this right. So 5 times negative 5 would be negative 25, and I times I would be I squared. I squared is negative 1. That would make the 25 become a positive 25. All right, now the top. Negative 8 times negative 5i would be positive 40i. And negative 2 times negative 5i would be a positive 10i squared. But the I squared makes the 10 become a negative 10. So let's see if we can clean this up. So we want A plus BI form. So A is the real part. That would be a negative 10 plus the 40i all over 25. And we're going to rewrite just a little. We're going to make the A part negative 10 over 25 plus the 40 over 25 is your BI. So that's A plus BI form. I believe we can do a little reducing here. 10 and 25 are both divisible by 5, so that would be a negative 2/5 plus 40 and 25 are also divisible by 5. That would be 8 over 5i. That would be our final answer. Go Bearcats. That's a good pre-cal problem. All right, once again, we're asked to write in standard form. We need to clear our denominator of its imaginary number. So we're going to multiply by the conjugate. The conjugate of 5 plus 6i would be 5 minus 6i. Therefore, we also need to do the same at the top, 5 minus 6i. All right, so let's go ahead and work at the bottom first. So 5 times 5 is 25. If they're conjugates, the middle term will always cancel. So we only have to do first and first, last and last. So now we have 6i times negative 6i. Well, 6 times negative 6 would be negative 36. And I times I would be I squared. The I squared would change your 36 to a positive. So that being said, 25 and 36 would be 61. Okay, we got the bottom. Now let's take a look at the top. All right, so we have 6 times 5, which is 30. We have 6 times negative 6i. That's negative 36i. We have 3i times 5, which would be positive 15i. And then we have 3i times negative 6i. That's negative 18i squared. I squared goes away. 18 we become a positive. All right, let's clean up our terms. So we have an 18 and a 30. That would be 48. That's our A. And we have negative 36 and a positive 15. I believe that's a negative 18i. And if we want to write it in the right form, we would have 48 over 61 minus 18 over 61i. A plus bi form. And I don't think you can reduce those. So that would be our final answer. Go Bearcats. All right, we're going to omit 19 and we're going on to 20. First, before we start multiplying, I really would like for you to go ahead and pull out the I. Okay, take out your I. So I'm going to rewrite this as 3 plus the square root of 5i. And I'm going to multiply times 5 minus the square root of 15i. And then I'm going to FOIL the two binomials together. So just be really careful. So you're going to go 3 times 5 is 15. And 3 times negative 15i is negative 3 square roots of 15i. All right, and then we have positive times positive. So positive square root of 5i times 5 would be positive 5 square roots of 5. Oops, sorry about my pen. I hope you could read that. Sorry about that. Oh, I don't like that, and my eraser and stuff isn't working very good tonight. Okay, sorry about that. Maybe I'll just do this. So plus 5 square roots of 5. Oh. I. All right, and then we have 5i times negative 50 square root of, the square root of 5i times the negative square root of 15i. So in that particular case, 5 times 15 is actually 75, and it would be negative square roots of 75, and I times I would be I squared. I squared is going to change our negative square root of 75 to a positive square root of 75. All right, hang in there on this problem. So the next thing we're going to do is we're going to try to put the real parts together. The square root of 75 is real and 15 is real. So I'm going to group those together. So 15 plus the square root of 75. And then I have minus, these both have i's in them, so the coefficient is negative. Let's do the positive one first. So I can make this plus. So a plus, and we'll say 5 square roots of 5, and then we'll say minus 3 square roots of 15, and then the I on the outside. Now, the reason I did that is because this is the real part, the A, plus the coefficient B, I. And you have to really think about this one. We have one last little thing to do. We need to simplify the square root of 75. So go over here and do that. So 75 divided by 5 would be 15. and divided by 5 would be 3. So we got a couple of 5s. That will come out of the house. 3 will stay home. So we're really going to write this as 15 plus 5 square roots of 3 plus 5 square roots of 5 minus 3 square roots of 15 I. Again, A plus B I form Go Bearcats. All right, in this problem, it's pretty quick and simple. You don't want to spend any more time than you need to on some of these. It says find all the zeros. Well, normally we have a big polynomial and we have to factor it out before we can find the zeros. This is already given in factored form. All you're doing is writing the zeros. So the 0, set each factor equal to 0. So x plus 5 equals 0. X would have to be negative 5. Here, x plus 3i equals 0, x would have to be negative 3i, and here x would have to be positive 3i, and those are my zeros, and that was it. All right, for right now, we're going to omit 22. I do like the problem, but for tonight, we're running a little short on time in my computer. I need to make sure my computer holds out. So we're going to go ahead and work 23, and then we're going to work 26. 24, we're going to, again, hold out on, and so on 25. But we're going to work 23 and 26, and that should get you pretty good practice, and you should be pretty good on your test. So let's go with 23. All right, this is 23, and we're going to talk about all the different things that you might need to do on your test and exactly how you're going to do it. So I'm going to work this problem just like it were a test problem with all the things that you would need to know how to do. First, you're going to want to be able to find its possible roots, the possible roots. That's your p's over q. So it's your plus or minus p over q. P are the factors of the constant, in that case 4. So the factors of 4 are 1, 2, and 4. Q would be the coefficient in front of the leading term. In this case, it's just a 1. So if 1 over 1 is 1, 2 over 1 is 2, and 4 over 1 is 4. So we would have positive and negative 1, 2, and 4. And you need to know if your teacher makes you write plus or minus in front of each of those or not. I'll let you write it right at the beginning. All right, the next thing you want to do is we're going to talk about Descartes' chart. And that's a really important chart, and we want to make sure that we're clear of that on our test. So when we do that, we're going to do positive, negative, complex, imaginary, and Ms. Zorn likes to do the total. But not everybody does that. Total number of zeros is 4. So it all has to add up to 4. All right, let's take a look at this polynomial. The first term is positive, the second term is negative, the third term is positive, and the last term is negative. Looking for sign changes. So positive to negative is 1, back to positive is 2, back to negative is 3. So that would be a 3, and decrease by 1 would be a 1. Remember, if you get a 1, you put a 1 underneath it. If you get a 0, you put a 0 underneath that. If you get anything greater than 1, you reduce it by 2 until you get to 1 or 0. So in other words, a 4 would be a 4, a 2, and a 0. A 3 would be a 3, and then a 1. All right, so next, let's think about if this x value were negative to the 4th power, that would still be a positive. If this x value were negative, it would be a negative times a negative 3, which would make it a positive. If this x value were negative times 6, it would be a negative, and 4, of course, is a negative. Sign changes. You stay positive, you go to negative, you have sign changes one time. So 1, and then, of course, I said a 1 underneath. 0, 0, or 1, 1. Add across. 3 plus 1 is already 4. You would have no complex imaginary. 1 plus 1 is 2, and you would have 2 complex imaginary. Remember, your complex imaginaries have to come in pairs. You can't have an imaginary number, a negative, under a root, which would create a plus or minus a negative number. You cannot have that imaginary number without having a second one. So just kind of be clear on that. All right, let's take a look at, now we're going to do some synthetic division to find our to find our zeros, and we're also going to graph. Let's see what we know about our graph before we get started though. Oops. All right, we know it's positive at the front. That would mean it goes up on the right. It's an even exponent. It would go up on the left. We know we have a y-intercept of -4. So down here, we're going to just say that's -4. All right, so that's what we know about our graph so far. Let's see if we can do a little synthetic division. A 4, a 3. Oh, notice there is no x squared term here. You got to put a 0 for synthetic division, a 6 and a negative 4. So we have a 1, a negative 3, a 0 placeholder, a 6, and a negative 4. All right. So we know that our possible roots are plus or minus 1, 2, or 4. So there's 6 choices there. We know we either have 3 or 1 positive and 1 negative. So we have, if you were asked how many positives, you would either have 3 positives or 1 positive. Negatives, you have 1 negative only, and you have 1. And complex imaginary, you could have 0 or you could have 2 of them. All right, so since it seems like we for sure have a positive and maybe have 3, let's start with positive, and we'll just start with positive 1 and see how we end up. Remember, as long as you get a 0, you can keep dividing by a reduced polynomial. If you don't get a 0, then you have to go back. You have to keep working till you find a 0. So let's try. What were our answers? Our possibles were 1, 2, and 4. Let's try 1. Bring down the 1. 1 times 1 is 1. That would be a negative 2. Negative 2 and 0 is negative 2. Negative 2 and 6 is a positive 4. And 1 times 4 is 4, and that is a 0. Aren't we lucky? All right, so now we have a 0, so at 1. So one of our solutions is 1, and at 1, we would have a 0. All right, so we have another point on our graph. Next, let's see if we can keep going. Okay. Something that we don't always look for, but you should always look for, we've reduced this to a cubic. And let's look to check to make sure we can't factor by grouping instead of having to keep synthetically dividing. So we would have an x cubed minus 2x squared minus 2x plus 4. And if we wanted to factor by grouping, we would divide here, or split it here, and we would factor out an x squared, and we would get x minus 2. And over here, we'd factor out a negative and a 2, and I believe we get x minus 2. I believe it worked. So in this case, we would have x squared minus 2, and we would have x minus 2. All right, well, x minus 2, the 0 is 2, and that's what we're looking for. So we know we have a 0 at 2. And now for x squared minus 2, we would have x squared equals 2. And we would square root, and we would have x equals positive or negative square roots of 2. Now, that is not an imaginary number. That is a radical, but it is not imaginary, so be really careful when you think that. The square root of 2 is between 1 and 2, and negative square root is between 1 and 2. So somewhere between 1 and 2, we get a 1, and then somewhere over here, between 1 and 2, we get a negative version of that. All right, so the other zeros here are positive or negative square roots of 2. So there's 4 solutions. We knew there were 4. We have 1, 2, 3 positive, and we have 1 negative, which is the square root of 2. So on our Descartes chart, we need to circle this top row. This is the row that matched our result. All right, and let's go ahead and grow in our graph. Okay, we know we go up on this side. We're going to come down. We have to hit there. Oops, I can't do this very good on this graph. And then back down, and then hit that, and then back up. All right, and our graph would look something like that. And we have, let's recap here. We've done our P's and Q's are possible. The word possible. Make sure you watch that. There's a difference between possible and real roots. Possible roots, Descartes chart, synthetic division to find the roots. These are our roots or our solutions. We graph it by using our roots and our solutions, and then I want us to go back and circle in our chart what matches. Okay, you have a problem. You have 2 actually on your test, very similar to this in the same processes. So make sure that you're really careful and pay really close attention to this problem. All right, this is the last one. We're going to omit 25, and if you want to know about 25, ask your teacher or ask me, and I'll be happy to help you. But we're going to omit 25 right now. And 26, we're going to work on just creating Descartes' rule of signs chart. So again, we have positives, negative, complex, imaginary, and Miss Zorn likes to do a total. So the total number of zeros should be 3. And then let's look at our chart. Okay, this term is positive. This term is positive. This term is positive, and this term is positive. Ah, positive, 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 positive. There are no sign changes, so we're going to have a 0, and what do we put under 0? 0. 1, 1, 0, 0. Everything else decreases by 2s. All right, if we put a negative in for the x, negative cubed would be negative, and a negative times positive 3 would make the whole term negative. Okay, if we take a negative and square it, it becomes a positive. Positive times a positive 3 would be a positive. A negative x would become a negative. And then, of course, the 4 stays positive. How many sign changes? Negative to positive is 1. Back to negative is 2. Back to positive is 3. There are 3 times it changes, so 3. And reduce it by 2, so 3 and 1. Add straight across. 0 plus 3 is 3. Can't get any more, that's 0. 1 plus 2 is 3. And there's our Descartes sign, rule of signs. So if you were asked how many positives, there would be 0. How many negatives? There would be 3 negatives or 1 negative. And how many complex imaginary? There'd be 0 or 2. All right, Bearcats, have a good evening. Don't forget, Miss Jenkins will be in the math lab in room 332 on Wednesday morning. And I will be there Tuesday morning, but you won't get this till after that. And I hope that you have a great day and a great evening tomorrow night, and study, study, study. I will see you later. Night, Bearcats.